So previously we controlled the Open Manipulator using service calls, but this time we're going to control it with a powerful package called MoveIt. So what MoveIt does, it's got a series of packages which will handle all the motion planning, the manipulation, the inverse kinematics, the control and the collision checking automatically for us. So there's a bit of information that can be read on the e-manual and on the appropriate GitHub site. So let's run up some code and see how it all works out. So we run the launch file that we get from the e-manual, and it's also listed on the GitHub site. It's going to run through the ROS launch procedure there. An error or two will pop up, and it's also going to launch RVs. We won't go into RVs too much. It is quite a fundamental skill that you'll need to learn with ROS, but it will be on the scope of these tutorials. So feel free to play around with RVs in your own time, but for the moment I'll just minimize it and move it to the side so we can see what happens as the arm moves. So we'll just skim back through this code. I'll just point out the errors that did occur when we launch. I haven't figured out or put much effort into solving them, but they are there, so just be aware of that. We can see what services and topics were executed. Probably a good idea to get familiar with what most of these lines, what they relate to. So that's it. So now we'll jump over. We'll actually execute a program. We'll execute the execute trajectory program that's written. This code can be found on GitHub. It's just a basic intro just to how to use MoveIt, just help people to get started and hopefully solve some of the problems where I got stuck. So I'll quickly cut to a video of the actual arm moving now. Okay, so I'll have a look at a few other commands. I've done these in a few of the other videos as well. So we'll just look at ROS service list. I'll also look at the ROS topics as well, just to show you guys what services and topics are running. I've found that Robotics often seem to change their packages a bit. Sometimes some services will be removed, some topics will be removed. So I'll just show you what I've been playing around with here. I've had a good look at most of these services and topics over the last few weeks. The one I'm looking at now is the controllers, which we're about to pull up now, listing the controllers, and we'll notice that the gripper is using a position controller. I'm actually trying to get my gripper to be current controlled, so that's the main reason for my research into this, is to figure out how to convert that to an effort controller. So hopefully by these videos it can help other people get started a bit quicker and they can plot along with it. So I'm also going to run, I'm going to echo the joint states topic and just go through the execute trajectory program again, and I just wanted to identify the amount of effort that the gripper was using. It's about -0.7, somewhere in that range, mainly because this is totally different to what the gazebo simulation does. The gazebo simulation, which I'll look at in another video, actually does use as an effort controller, and its effort sits around 0.1 the whole time. So yeah, that's what I'm going to play around with from here. So I just want to show you guys that, and hopefully it helps you get started.